Hello everyone, I am Priya Karfa, an assistant professor of BSH. Today, now we are going to discuss about the Newton's forward interpolation formula. What is the Newton forward interpolation formula? Let's take a discussion. At first, now we take a mathematical example about the Newton interpolation formula. This is the example. Given the following table and find y equals to y of 0.16 using Newton's forward interpolation formula. At first we know that what is the interpolation formula. Newton's interpolation formula. At first let y equal to fx be a function, be a not only a function, this is a real valued continuous function, real valued continuous function, then we take equispaced points, n plus 1 equally spaced equispaced points. What is the points? x0, x1, x2 up to xn plus 1. This is this is not xn plus 1, this is xn. Okay, now here we introduce s is, what is s? X minus x0 divided by h, and here h is the step length. Now we get the interpolation formula fx, and at first we take a polynomial. What is the polynomial? Px. We introduce as px. Px is equals to x minus x0, x minus x1 up to x minus xn. And now we get the interpolation formula fx nearly equal to px, small px is equals to y0 plus s delta y0 plus s into s minus 1 divided by 2 factorial delta square y0 plus up to s into s minus 1 s minus 2 dot s minus n plus 1 divided by n factorial delta to the power n y0 plus some error ex, where error formula is ex is the error, and error formula is equal to f to the power n plus 1 xi divided by n plus 1 factorial times x minus x0 times polynomial. That means polynomial is this x minus x0, x minus x1, x minus x2 up to x minus xn. So we discuss this mathematical example we apply by Newton's forward formula, interpolation formula. At first, this is the table here given in the question. X, y, x values is 4 values 0.1, 0.2, 0.3, 0.4, and this times 2 0.1, so our y value is 1.005, 1.020, 1.045 and 1.081. Now we discuss the solution, and this is the difference table. This is the difference table. The table is 0.1, 1.05, 1.020, 1.4045, 1.081. Now we subtract these two gaps. This here we discuss polynomial is x minus x0. So gapping is here we put. Now here put 1.020 minus 1.005, and this calculation is 0.015. This process is continuing. Here we also apply 1.045 minus 1.020, and here the result is 0.025, and here also apply. This process is also apply the forward difference table. Delta is, our previous class we say that what is the delta? Delta is the forward difference operator. Forward difference operator. Now here we apply forward difference table operation. What is the forward difference operation? Delta y is equals to y1 minus y0. Sum our degree is higher than 1, then delta square y is y2 minus y1. This process is continuing. So here we apply this process and continuing delta square y and also delta cube y. Now what is the find out? Find y of 0.16. That means find f of 0.16. So here we to find f of 0.16, we put at first what is the x values? X values are given in our question. These values is our x values. So x we put x equal to 0.16 and x0 our initial value. So initial value, if I choose 0.2 or whatever, 0.1 maybe, 0.3 maybe, 0.4, but I choose x0 is 0.2. So x0 is 0.2 and h, our step length, this gap. So h is 0.1, and we told also again s is our interpolation formula. We introduce s is equal to x minus x0 divided by h, and we put all the here and our result is minus 0.4. This is the s values. Then using Newton's forward interpolation formula, f of 0.16 nearly equal to y0 plus s delta y0 plus s into s minus 1 by 2 factorial delta square y0 plus s into s minus 1 times s minus 2 divided by 3 factorial delta cube y0 plus up to continuing up to nth term. But here our difference table is just third terms is end, then we take delta cube y0. Now here we put at first y0 value. Our difference table is at first y0 value is 1.020 because our x0 value is 0.2. So this term is y value is 1.020. So 1.020 plus s value is here minus 0.4. We put here into delta y0. So our delta y0, that means 1.020 diagonally 0.025. So at 1.020 delta y0 0.025. Now here we calculate s into s minus 1 minus 0.4 minus 0.4 minus 1 divided by 2 factorial times delta square y0. Delta square y0 0.25 diagonally 0.011. So delta square y0 value 0.011. Then we solve this decimal point into here 2 factorial. After calculation we get the result 1.01308. But here we take correct up to 3 decimal places. So 1.013 is our result, f of 0.16. So now we are going to discuss in Newton's forward formula how to apply Newton's forward interpolation formula and solve the mathematical problem. Thank you.